NCM Learning Center.
Good morning friends. In the part 2 videos, we are going to discuss about the GATE 2022 ECE department questions and solutions from circuit theory. These concepts is very useful for electrical, ECE and instrumentation students. In the part 1 videos, we discussed the GATE 2022 electrical engineering questions and solutions from circuit theory. Now we will solve these questions. In the ECE GATE 2022 examinations from circuit theory concepts, totally 5 questions are asked. Out of the 5 questions, 2 questions are 1 mark questions and the remaining 3 questions are 2 mark questions. So totally 2 into 1 2 plus 3 into 2 6. Totally 8 marks from the circuit theory concepts. So we will discuss one by one. The first question, the objective of the question is we have to find the current flow 32 kilo ohm resistance, the current values. We may use mesh analysis and nodal analysis. Already we discussed the both mesh analysis and nodal analysis concepts. If you don't know the mesh analysis and nodal analysis concepts, just refer that video. Here, which method is best? Mesh analysis or nodal analysis? Here, number of mesh is 2, 1, 2. But number of nodes, only 1. So, if we use the node analysis, the method will be easiest. Compare with mesh analysis. Because number of nodes is 1, number of mesh is 2. So, we may use node analysis here. For the node analysis, first we have to find number of nodes and we have to assume the node voltage. Here number of node is 1, so we assume the node voltage is V. Because only one node, so V. The opposite node is ground node. Okay. By the node analysis, we have to assume the current flow from the node. So assume that this current is I1, next is I2, this I3. The assumed current should flow from node. Now use the Kirchhoff's current law at node. We know that Kirchhoff's current law, sum of incoming is equal to sum of outgoing. Here all the currents are outgoing currents. So outgoing currents I1 plus I2 plus I3 is equal to 0. Because there is no incoming current. Now find I1 value, I2 value, I3 value, substitute here, you will get your answers. So, for I1, by the Ohm's law, the I1 is V minus 5 divided by 2 kilo ohm. V minus 5 by 2 kilo ohm, 2 kilo ohm, 2000 ohm. Then I2 value, here this is ground node 0 volt, so V minus 0 by 2000, so V by 2000. Then here this current source is given. The current value is directly given. But the I3 and this current source are in opposite direction. So the current value will be negative. 10 power to minus 3 ampere. That means 0.001 ampere. Okay. Now simply with this equation, we'll get node voltage. V is equal to 3.5 volt. But our objective is to find the current I. The current I flows from 5 volt. So, by Ohm's law, current I is equal to 5 minus V by 2 kilo ohm, 2000. So, already we know that V value, substitute here, will get I is equal to 0.75 milliampere. So, option B is correct. Okay. Now, we will solve the second question. This question is one more question. We may use mesh analysis and node analysis also for this problem. If we use mesh or node analysis, we will get the answer as 0.1 ampere. Okay, if it is a ground, if we consider this ground node, this point is ground. Remember that here ground is not marked. This is not grounded. If it is a grounded, if you use mesh analysis, node analysis, any one method, you will get answer as 0.1. But this is not grounded. This is isolated. This is open. This is not neutrally connected. There is no return path. So the current value I is equal to 0 amps. So option B is correct. But if you consider this is a ground node, this is connected with this, then there will be a return path. If we use mesh or node analysis, we will get 0.1 ampere. But here there is no ground, there is no return path. a single point. Okay, there is no return path, so the answer will be a 0 amps. Okay. Now we will solve the third questions. This is two more questions. Objective of the question is we go to find the values R1 and R2. Here the relation is given, frequency versus impedance. Just observe the graph. By the graph, when omega is equal to 0, what is the value of impedance? Z is equal to 5 kilo ohm. When omega is equal to infinity, this point is omega is equal to infinity. When omega is equal to infinity, the impedance Z is equal to 2 kilo ohms. Imaginary time is 0. In the impedance, imaginary time is 0 when omega is equal to 0 and omega is equal to infinity. Okay. Know that the relations between reactance Xc and omega. X is equal to 1 by omega c. When omega is equal to 0, what is the value of Xc? X is equal to infinity because Xc and omega are inversely proportional. If X is equal to infinity, what will happen? If X is equal to infinity, the capacitor acts as open because reactance is infinity. Reactance means resistance to the alternating current. The resistance is infinity means there is no way to flow the current. Current value will be 0. So here X is equal to infinity means the capacitor acts as open because there is no current flow here. So if it is open means what is the value of impedance for the circuit? Z is equal to here R1 and R2 are in series because this path is open. Okay, only one path. So R1 and R2 are in series. So we will get Z is equal to R1 plus R2. When omega is equal to 0, by the graph Z value is 5 kilo ohm. But by the circuit, when omega is equal to 0, Z is equal to R1 plus R2. So equate this, Z is equal to R1 plus R2 is equal to 5 kilo ohm. Now let us take this equation as 1. Now when omega is equal to infinity, what is the value of Xc? Xc is equal to 0. 1 by infinity is equal to 0. So if X is equal to 0, what will happen? What is the effect of capacitor? Resistance 0. If resistance 0 means short circuits. Maximum current will flow. Short circuits. So capacitor acts as short circuits. Now replace the capacitor by short. Okay. If it is shorted, R2 and the 0 resistance, this means 0 resistance. R2 and 0 resistance are in parallel. So the resultant will be 0. The 0 ohm impedance is seriously connected with R1. So we will get total impedance Z is equal to R1. Okay. When omega is equal to infinity, what is the level of resistance by the graph? Substitute here, we will get Z is equal to 2 kilo ohm. Let's take this equation number 2. Solve this equation 1 and 2. We will get Z1 R1 is equal to 2 kilo ohm, R2 is equal to 3 kilo ohm. So answer option A is correct. Now fourth question. Objective of the question is we go to find the element Z and the value of this Z. Okay. By observing the graph and circuit we go to find. First observe the graph whether current is lagging or leading. If current is lagging means the element will be an inductor. If it is current leading means the element should be a capacitor. So we go to find. By observation of the current graph, this graph we can find whether it is an inductor or capacitor. Okay. So at t is equal to 5,4, what is the value of current I? I is equal to 0. From this graph at t is equal to 5,4, the value is equal to 0, current is equal to 0. So we may represent this current equation as I of t is equal to, here magnitude is maximally I am is equal to 1 by root 2, so 1 by root 2 sin t minus 5,4. Because at t is equal to 5,4, the value will be 0. Okay, when t is substitute here, when t is equal to 5,4, we will get sin 0 value will be 0. Okay, it is lagging or leading? It is lagging. Yes, minus. It is lagging one. So current is lagging. Current lagging means the element should be a inductor. So we may eliminate this option A and C. Okay, A and C is wrong one. The answer may be a B or D. Okay, we got to find which one is correct. From the circuit, V of t is given. V of t is equal sin t. From the voltage, we can find the angular frequency omega is equal to 1 radian per second, because the standard formula voltage V is equal to Vm sin omega t. Vm value 1, omega value 1. Okay, omega is equal to 1. Find the impedance from the graph. Impedance means Vm by Im. Here Vm is equal to 1. Vm is equal to 1. Okay, Vm is equal to 1. Im value is 1 by root 2. So we will get Z is equal to root 2. Impedance value from the graph. Here Vm value is given 1. Im value is 1 by root 2. So we will get impedance Z is equal to root 2. Okay. So from the circuit, what is the impedance Z? Z is equal to root of R square plus omega square L square, because R and XL are in series. So we will get root of R square plus XL square. XL means omega L. Substitute this omega value, we will get Z is equal to root of R square plus L square, that is equal to root 2. So simplify this equation, we will get R plus L is equal to 2. Here R value is already given 1 ohm. Substitute here, we will get L is equal to 1 Henry. So option P is correct. Inductor with a value of 1 Henry. Okay, good. Next, final questions. Two-port network is given. Already we discussed two-port concepts. Just refer that video. Okay. So objective of the question is, from the two-port network, here V2 I2 relations is given. When the load is replaced by the circuit, figure B, what is the value of I2? Condition is given. When V2 is equal to, when I2 is equal to 0, V2 value is 5 volt. When I2 is equal to 4 milliampere, V2 is equal to 4 volt. V2 I2 relation is given. Okay. For a circuit, if you find the Thevenin circuits for the two-port network, it will be easiest. Okay. Without the Thevenin circuits, the problem will be a complex one. So first convert the equivalent circuits. Convert the two-port network into its equivalent Thevenin network. If you convert the Thevenin network into equivalent simplified resistive network, the analysis of the resistive network is very easiest than two-port network. So first you will convert. Already we know that how to convert the two-port network into Thevenin circuits. Already we discussed in the part 7 videos. Just refer that. So first we go to find the Thevenin's voltage. What is Thevenin's voltage? Thevenin's voltage is open circuit voltage. Okay, we would remove the load and find the voltage across the load. Okay. So under open circuit, what is the value of load current? I2 is equal to 0. Okay, load current is I2. When the load is open means current flow through the load is 0. So I2 is equal to 0. When I2 is equal to 0, at this condition V2 is equal to open circuit voltage or Thevenin's voltage. This is already given. When I2 is equal to 0, V2 is equal to 5 volt is already given. So VTH is equal to VOC is equal to 5 volt. Okay, is already directly given. Thevenin's voltage is directly given. Now we go to find the Thevenin's resistance. How to find the Thevenin's resistance? Thevenin's resistance RTH is equal to open circuit voltage by short circuit current. Okay. So open circuit voltage, Thevenin's voltage is already known. So we go to find short circuit current. What is short circuit? Short circuit means the load is removed and shorted. At the short circuit condition, load voltage V2 is equal to 0. So when V2 is equal to 0, that is equal to short circuit. When V2 is equal to 0, that means short circuit condition, the value of I2 is equal to short circuit current. So we have to find the I2 when V2 is equal to 0. Okay. How to find? You may use the line relations. Two point is given, we can find the line equation, from it we can find. Or otherwise, by analyzing the two-port network, we can find. Here V2 I2 parameter is given, so ABCD parameter analysis is better than other parameter network analysis. So equation, what is the characteristic equation of ABCD parameter. For the ABCD parameter, the load current should be towards the load side, but here is the opposite side. So we have to consider this is negative value. So V1 is equal to AV2 minus BI2. If it is current direction towards the load side, the formula V1 is equal to AV2 plus BI2. But here the load current is opposite of load side. So this is, so we get the minus value. Next, I1 value is equal to CV2 minus BI2. Okay. Substitute this condition, find the values of A and B. From the circuit, V1 value is directly given. V1 is equal to 10 volt. 10 volt is directly given. So just apply just hold it this side, we will get V1 is equal to 10 volt. Okay. Substitute this condition, when V2 is equal to 5 volt, I2 is equal to 0 milliampere. Substitute this condition, we will get V1 is equal to 10, A, V2 value is equal to 5, I2 value is 0. Okay. So A is equal to 2. A parameter is no. Okay. Next, find the B value by using other conditions. These conditions. When V2 is equal to 4 volt, I2 is equal to minus 4 milliampere. Substitute this condition. In this characteristic equation, you will get V1 is equal to 10 volt. A into V2 value 4 minus B into I2 value minus 4. Already we know that A value is equal to 2. Substitute these values, A values here, and find the B values. Here 10 is equal to 4A plus 4B, A value is 2, we will get 8. So B value is equal to 0.5. Because A value is already known, 2. Now substitute this A values and B values in this characteristic equation, we will get 10 is equal to V1 is 10 volt. So 10 is equal to AV2, 2V2 minus B value 0.5 I2. Okay. But our objective is to find I2 value when V2 is equal to 0. Substitute this condition, when V2 is equal to 0, what is the value of I2? I2 is equal to, IS is equal to 20 milliampere, because here 10 is equal to 0.5 I2, we will get minus 20 milliamps. Short circuit current is no. Okay. Now we got to find Thevenin's resistance RTH. RTH is equal to open circuit voltage by short circuit current. Substitute these values, both the values, we will get RTH is equal to 250 ohms. Okay. Now what is the value of Thevenin's circuits? This is Thevenin's circuits. VTH is equal to 5 volt. RTH is equal to 250 ohm. This is load. This is load current. This is the equivalent representation of two-port network circuits. Now replace the load R by figure C, 1 kilo and 10 volt. We got to find the current I2. Okay. What is the value of I2? I2 is equal to, from this Ohm's law, 10 minus 5, this two are series. This is 1000 ohm, this is 250 ohm. So we will get 1250 ohm totally. So I2 is equal to 10 minus 5 by 1250 ohm. So we will get answer as 4 milliamps. This is the answer. Okay. If you have any doubts related to the discussion, just post your doubts in our NCM Learning Center WhatsApp group. You can get the clarification. In the part 3 videos, we will discuss the instrumentation department questions from circuit theory concepts. Okay. Visit our website www.ncmlearningcenter.com. You can get the video materials for GATE, IES, ISRO and other competitive examinations. Then PDF materials, PDF book materials prepared for NCM Learning Center. If you use this material, definitely you can get the good marks in the competitive examinations. Then you can get the test series. Join our WhatsApp group, NCM Learning Center WhatsApp group. That link is attached in the description box of the video. Join in our group. If you have any doubts related to the discussion, just post in the WhatsApp group. You can get the solutions. Okay, good. Thank you.
Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.